Hello and welcome back to my channel. Today we are going to discuss question number 6th, 7th and 8th from specimen paper 2020, and it is 970901, that is pure mathematics 1. So let's start with the question number 6. And here is the question number 6a part. Find the coefficient of x square and x cube in the expansion of 2 minus x whole to the power 6. So it's a binomial expansion question, so we'll expand it. And we know that it is going to be 2 minus x to the power 6 as 6c0, so 60, and 2 raised to the power 6, and we'll write minus x. We can understand it as 2 plus minus x, so to the power 0, plus 6c1, and then 2 raised to the power 5 and minus x to the power 1, then 6c2, 2 raised to the power 4 and minus x to the power 2, plus one last term 6c3, 2 raised to the power 3 and x minus x to the power 3, and the rest we don't require because we only require the coefficients of x square and x cube. So we are going to solve this and this. So coefficient of x square would be 6c2, 2 raised to the power 4, and it is going to be x square, so no need. 6c2 is 15 and 2 raised to the power 4 is 16 now. So 16 5s are 80, 16 1 is 16, and 8 is 24. So the coefficient of x square is 240. Similarly, the coefficient of x cube would be 6c3, 2 raised to the power 3, and from here we'll get minus x cube, that is going to be minus, so we'll apply minus here, and it is 6c3 is 20 into 2 raised to the power 3 is 8, 8 2s are 16, so it is minus 160. That is the coefficient of x cube. I hope it is clear. Let's do the b part of it. Now here's the b part. Hence find the coefficient of x cube in the expansion of this. So we can see the first one is a linear equation, first bracket. So in order to get the x cube, we require, for x, if we'll multiply with x square, we will get x cube, and from 1 for this constant term we require to get x cube, which we have from the previous part. So it is going to be 3x plus 1 multiplied by, because we require coefficient of x cube, so we require coefficient of x square and coefficient of x cube. Other things we don't require to highlight plus and all. So 3 into coefficient of x square, that is 3 into 240, plus 1 into coefficient of x cube, and that is going to be minus 160. So altogether this will be the coefficient of x cube, and it is 0, 2, 3 2 is 6, plus 1 7, minus 160. So it is 0, 6, and 6 minus 1, that is 5. So coefficient of x cube here in this expansion is going to be 560. I hope it is clear. Let's do the next question now. Here is the question number 7a part. Show that the equation 1 plus sin x tan x is equal to 5 cos x can be expressed as this. Since in the AS level we have only two identities, one is tan x is equivalent to sin x over cos x, another is cos square x plus sin square x is equivalent to 1. So here we can see tan x. So first of all we'll convert tan x into sin x over cos x. So we will get 1 plus sin x into sin x over cos x is equal to 5 times cos x. And since we require cos square, means cos term here, so we'll convert sine if however it is possible. So let's multiply by cos x everywhere. We will get cos x here, plus if we'll multiply cos x here, this would be cancelled, so we are left with only sine square x is equal to 5 times cos square x. Now sine square x is 1 minus cos square x, another identity, so it is cos x plus 1 minus cos square x is equal to 5 cos square x. Let's translate everything to the other side. We will get 0 is equal to 5 cos square x minus it is going to be plus, and this is minus cos x and is minus 1, or we can write it as 6 cos square x minus cos x minus 1 is equal to 0. Hence we are done. Let's do the b part of it. And here's the b part. Hence solve the equation this for x between 0 and 180 degree. So we need to find the angles between 0 and 180 degree. And from the first part we have seen that this can be expressed as 6 times cos square x minus cos x minus 1 is equal to 0. Now we will factorize it. It is 6 into 1 6, and 6 can be written as 2 into 3, and if we take the pair 2 and 3, we will get minus by taking minus 3 plus 2. So it is 6 cos square x minus 3 cos x plus 2 cos x minus 1 is equal to 0. Since it is quadratic in cos, so we will solve in this way to get the two roots. And here it is 3 common and cos common. We are left with 2 cos x minus 1. From here it is 1 common, so again 2 cos x minus 1 is equal to 0, or we can write it as 2 cos x minus 1 in one bracket. In another one it is 3 cos x plus 1 is equal to 0. So we will get two values of cos x. Cos x is equal to 1 over 2, and cos x is equal to minus 1 over 3. So from here cos x, if cos x is 1 by 2, x is going to be 60 degree, because we know for cos x 1 by 2 it is 60 degree. So next value for cos is going to be either 360 minus theta or 360 plus theta, which will give the value which is going to be more than 180. So we will not consider, that is going to be only 60 degree. From here we will calculate this value from calculator. Cos inverse of 1 over 3 in the degree, cos inverse of minus 1 over 3 is 109.47 and all, and we will write this, since it is a degree, so we can write it in one decimal place or 3 significant figure. So it is going to be either 109 degree, or we can say 109.5 degree. So I hope it is clear. Let's do the next question now. Here's the question number 8. A curve has equation y is equal to 12 over 3 minus 2x. First part is to find dy over dx. So it is of 12 over 3 minus 2x. We can write it as, we'll write y as 12 times 3 minus 2x to the power minus 1. So let's differentiate it. That is dy over dx would be 12 times minus 1, then 3 minus 2x to the power minus 1, and by chain rule we'll differentiate the bracket as well, and which will give us 0 minus 2, that is going to be minus 2, and hence we will get it as minus minus plus, 12 2s are 24, and this is minus 2, so we can write it as 3 minus 2x in denominator and power is 2. So ultimately we got 24 over 3 minus 2x whole square. Let's do the B part now. Now here's for B part. A point moves along this curve. As the point passes through A, the x coordinate is increasing at a rate of 0.5 units per second. Means dx over dt is given as 0.15, and y coordinate, it is at A because it is passing through A, then only at A this is there, and the y coordinate is increasing. Dy over dx is dy over dt is also given as 0.4 units per second. Now find the possible x coordinates of A. So it is at A, this is given, and from the previous part we know that y is equal to 12 over 3 minus 2x. So we are going to make a relation between them, and we know that is dy over dx is equal to dy over dt into dt over dx by chain rule. So let's say at A it is there, and from the previous part we have seen dy over dx is 24 over 3 minus 2x square is equal to dy over dx is 0.4, and since it is dt by dx means dividing by this, so it is going to be divided by 0.15, or we can write it as 40 over 15 to remove decimal, same number of decimal places, and so we'll solve it now. So from here by cross product we got 3 minus 2x whole square multiplied by, I cross multiplied with this, so it is into 40 is equal to 24 into 15. So 8 5s are 40, 8 3s are 24, 5 1s are 5, 5 3s are 15, so it is 9. It means 3 minus 2x square is 9. So we'll solve for x. It is 3 minus 2x is plus minus root 9, that is 3. So with positive sign we'll get 3 minus 3 is equal to 2x. That means x is equal to 0, and with negative sign it is minus, so it will go there, that become plus. 3 plus 3 is equal to 2x, which will be 6x is equal to 6 is equal to 2x, means x is equal to 3. So the possible x coordinates of A are 0 or 3. That's the answer. I hope it was of some help. We'll discuss next few questions in the next video. Till then, thank you so much.